Okay, welcome to Introduction to Weather with Lab or Weather Studies. The course content comes from the American Meteorological Society, so we are an umbrella organization for meteorologists in the United States. So we're going to start just trying to define what is weather. So let's take a look at that first. If you were walking outside, maybe how would you define weather? Would you define it, oh, I feel cold. That's all I need to know. Or I'm wet. Or maybe it's really windy today. It's hard to walk. Or would you want to know all those things? So weather is all of what I just mentioned and a lot more. It's your temperature, humidity, but weather is the state of the atmosphere at a very specific place and time. In other words, if you walk outside your door at one instant in time, that moment, you describe the weather. Not 10 minutes before you walked out, not 10 minutes after. It's that moment in time. I want to stress that. Everything in weather is described as right now. So we pick a time. Say, I want to know what the weather is or was at 7 a.m. this morning. Well, I need to know then what the weather is at 4 a.m. out in California because that matches with the 7 a.m. here in the Eastern time zone. So I put all of that together. The weather map is drawn at exactly the same time. Even if 4 a.m. is a different time, it's exactly the same. It equals 7 a.m. Eastern time. So we look at all of that when we're putting a weather map together. All the times must match. So also meteorology is basically just the study of the atmosphere or weather. Climate, looking at more long term, and climatology is what controls our climate. So we'll get into those things with time here. There are two main types of pressure systems, we'll say. Air pressure systems. Air has a weight. And if I told you, oh, low pressure was coming at you, it means the weight of the atmosphere is getting less. So, hey, you should be able to jump higher, right? I doubt it. But it is a little bit less weight on you. High pressure means more weight. High pressure associated with good weather. Low pressure with bad weather. And around these are cold and warm fronts. And they mean exactly what they state. A cold front, if a cold front passes your house, the air will get colder. If a warm front passes your house, the air will get warmer. That is what they mean. Literally right where the words are. You define a cold front as moving cold air through you. You define a warm front as warm air that's advancing. Winds blow around these weather systems. Around the high, the winds are clockwise. Around the low, the winds are counterclockwise. Something you will see a lot in this course is wind direction and speed. And you need to know that around high pressure systems, winds blow clockwise. Around low pressure, they blow counterclockwise. Air masses are just masses of air that cover large areas, hundreds of thousands of square kilometers, and they have the same type. In other words, you ever watch when a cold front moves through your house, temperature drops, and it reaches a certain level, and it stays around that area while that air mass is passing you. The fronts separate these air masses. In other words, when a cold front comes through, a cold air mass is coming in. When a warm front comes through, a warm air mass. They originate in different parts of the world. Warm air is lighter than cold air. We'll talk about why that is here in a little while. So that means if a warm front is advancing towards your area, the warm front aloft will actually pass your house before the warm front at the surface. So the temperatures aloft are warming so that the actual warm front passes you aloft first. Cold front, on the other hand, when it's moving through, is pushing the warm air up out ahead of it, so it's steeper, will tend to push the warm air up faster. So we just described a lot about the state of the atmosphere a minute ago. So we'll move on here to look at clouds a little bit. We like to talk about clouds in this course because when you look at clouds, you're seeing what the weather is in some ways. Clouds, high clouds, are basically ice. The air gets colder as you go up, so there's a lot of ice up there. Lower clouds are more water. They have more liquid in them. And you'll notice the difference. Cirrus clouds look wispy. Lower clouds have more defined edges, look darker, because the water appears darker to you. Fog is just a cloud that's in contact with the ground. There are types of clouds like stratiform clouds, which are just sheets of clouds, uniform, where the air is just gradually ascending, causing a broad area of cloud. Cumuliform clouds are puffy. We get these all the time in the summertime. You can walk outside many times and just see clouds building up, bubbles, I call them, in the sky. And here you can watch and see the one that's here. Clouds move in different directions. Air moves always different directions depending on altitude. So maybe aloft the air is moving out of the west, while at the ground it's moving out of the south. So if you have some real low clouds down close to the ground, they're going to move from the south, while the ones aloft are moving out from the west. So that's how you kind of get an idea of wind direction at different altitudes in the atmosphere by looking at clouds. So I wanted to just go over here a minute. This is a surface weather map. So we talk about high pressure. Right in the middle, northern part of the U.S. right now we have high pressure, 1021 millibars. Millibars are a unit of measure in the metric system. And here is low pressure down here. So you can see that there's a contrast between the two. And we're going to be looking at that. We also see the cold front that's coming through Ohio right now, or a warm front that's coming through Kentucky. So let's take a look then at one of the first exercises you're going to be dealing with. You're going to look at a pressure map. And a lot of you are going to say, what is that? All right. I don't know how many of you have ever looked at a topography map or went hiking using topography, trying to figure out a route that didn't make you go up and down too many hills. Well, think about it. The Earth changes elevation all over the place. You don't know where. And somebody went around and picked a whole bunch of points that had those elevation changes and just connected the dots. Where every elevation was the same would have one line, and where another line would be where another elevation is all that number. That's all air pressure is. You are connecting the dots. So if I wanted to connect a 1020 millibar line, I'm going to look, well, where would 1020 be? Well, here I have 1021, I have 1018. Well, 1020 is going to be just closer to the 1021 than the 1018. Here's a 1020, so I can put my thing right there. Oh yeah, I got 1020 up here, so I just kind of draw up that way. There's 1020 again up here. And there's 1017 and 1023, so not halfway between the two of those. I've just connected my line. I have made a full line. And I know that everything on this side of that line, to the right of the line as I was moving, is all higher pressure. So if I'm looking for some of the highest values of pressure, I better be finding them right here. Here it is, 1024 millibars. So if I'm looking for the lowest pressure, I'm looking where, 1016 millibars is the lowest one I have drawn here. There's some lower out here. If I did 1016, I could draw another 1016 out here as well. So I'd have some lower pressure down in southwestern U.S. as well. But right now, what I'm seeing is the lowest pressure on this map is 1011. So that would be my low pressure system. I'd have another one down here somewhere too, 1012, 1012 here. So I'd have another area of low pressure out in the mountain, Rocky Mountains or Southwest U.S. So that is one of the first things you're going to be looking at. Now, in the second chapter, we're going to be dealing with station. We talked about what you define weather as. So one of the first things I want to know when I'm going outside is what's the temperature. So these are just plotted at one point. So say Columbus might have a station. Maybe Cincinnati would have a station. Maybe Toledo. So, but nothing in between, we'll say. So each one of those points has a station symbol that looks like this plotted on the surface weather map. Maybe I deal with Los Angeles, California. Same thing. Station symbol like this. All at the same time. So I want to know temperature. Well, here's temperature, upper left-hand corner of this station symbol. And dew point's the lower left-hand corner. So it is a little bit less. It's a measure of moisture. But notice how close they are to the same number, 57 and 56. Relative humidity, the amount of moisture the air can hold. When it's 100%, the moisture can't hold anymore. The air can't hold any more moisture. Well, if they're close to the same number, we're getting very close to 100%. So this is very close to 100% relative humidity. The air is almost completely saturated there at the surface. What's the weather? Well, that's something I'd like to know. There's 3 dots. Dots indicate rain. 3 of anything indicates a moderate amount. So this is moderate rain. If these were stars, they would be snow. And if you had 3 stars, you'd have 3 moderate snow. If you had 4, you'd have heavy. If you have 2, you have light. Another thing I want to know is what the sky covers. If I want to look straight up, how much of the sky is covered with clouds? Well, it's completely opaque here. You don't see anything except covered. So that means that right here at this location, the sky is cloudy. Another thing I need to know is pressure. We've just talked about pressure. Well, and notice in that pressure map that I dealt with 1021, 1011, 1019, or whatever. There were 4 digits. Well, this doesn't have 4 digits. No, it doesn't. The last digit here is the 10th. So I need to put 2 digits in front of this to make it a 4-digit number. Well, if the pressure is less, is 500 or less, put a 10 in front of it. So this is 1010.7. No. Now, if I have the low pressure system moving through, maybe the air pressure here is 898, we'll say. Well, if I put a 10 here, I'd have 1098.8 or 898, I said, I guess, 1089.8. That seems awful high. What it actually needs is a 9. If I put a 9 there, it's 989.8. So that would be your new air pressure. So if the pressure is above 500, put a 9. If the pressure is below 500 on this sea level, put a 10. Now you've converted everything to a usable unit that you can measure. So I hope you got something out of this, and please don't hesitate to ask with any questions.